Hi everybody, it's time for video 3 of lecture module 7, continuing our discussion on Mars. This video is all about the Martian atmosphere, because yes, Mars does have an atmosphere, albeit a rather thin one. We can go ahead and take a look at the Martian atmosphere. So this is from Viking 1. It's actually just taking a picture of the Martian atmosphere, and here you can see it. Down here is the surface of Mars. So yes, Mars does have plenty of impact craters. They are quite eroded, but that's because there is an atmosphere. And with an atmosphere, then we can talk about wind erosion, the dominant form of erosion on Mars. So Mars, while it has an atmosphere, it's not very thick. So the mass is about 1/150th of Earth's atmosphere. So it is a very thin atmosphere, but it's still an atmosphere. Let's go ahead and take a look at what the atmosphere is structured like and its atmosphere composition. So here we have our temperature versus altitude plot. And we can see that while you're going up, the surface is the hottest, and then it gets cooler as you go up. So we are going through the troposphere. The stratosphere is just defined as what's really above the clouds. And then you can you have a few little turnovers. But really, I'm going to focus on mostly what's going on within the atmosphere. So as I was saying, it's a thin atmosphere. It is about 1/150th of Earth's atmosphere, which gives it a surface pressure of about 4 to 9 millibars. Now, I know that's a new unit, but just 1 millibar is about the same as a milliatmosphere. Bars and atmospheres are very, very close, but we tend to measure the surface pressure on Mars using bars rather than atmospheres. So it's 4 to 8 millibars. Notice that varies quite a bit, and it's going to vary based on season. So depending on what season it is on Mars, there's going to be a different amount of atmosphere. I told you, Mars has some complicated seasons going on, where even the amount of gas in the atmosphere changes drastically. So out of the atmosphere that's there, what is it made out of? So Mars's atmosphere is primarily, just like we saw with Venus, a carbon dioxide atmosphere. So out of all the gases that are there, the most abundant gas is carbon dioxide, 95.3%. What is the second most abundant gas? No surprise, nitrogen. So that same process that built up nitrogen in our atmosphere would have happened with Venus, and now it also would have happened with Mars. It's a generalized process. So no surprise that the second most abundant thing is nitrogen. The third most abundant is argon. Again, similar to what we see here on Earth. The big difference, however, is that it is a mostly carbon dioxide atmosphere that's extraordinarily thin. A very interesting fact about the Martian atmosphere: the day-night cycle being such a thin atmosphere, between day and night, there is a huge temperature fluctuation on the Martian surface. So this anchor point right here will swing down to lower and colder temperatures, making the curve upward less, so it doesn't get that much colder as you go up. That actually cuts off convection. And if you don't have convection occurring, you can't really define it as the troposphere. So while there's still an atmosphere there, Mars loses the troposphere, where there's actually convection occurring during the nighttime, which means that weather pretty much shuts down at night on Mars. Still have atmosphere there, but no real weather to talk about. One of the biggest weather events that happens on Mars, and very notable, and most people are very aware of this because of the movie The Martian, is Mars is known for dust storms. And the dust storms on Mars are absolutely insane. They are much, much, much greater than any dust storm we see here on Earth. And periodically, about 1 to 3 times per Martian year, you will have dust storms that kick up that would be the size of a continent. So North America size dust storms. Imagine all of North America in one giant dust storm. That's a pretty strong dust storm. It's even crazier. It only happens on average about every 5.5 years. It's not periodic. We can just talk about how often it occurs on average. Are global dust storms. So every 5.5 years or so, Mars will experience what we call a global dust storm, where the entire planet is in one giant dust storm. So here you can see before the dust storm kicks off. This is from 2001. Here's after the global dust storm really got raging and is coating the entire surface, covering the entire surface of Mars. So Mars will experience global dust storms. Here's a simulation of the skies for, say, the Opportunity rover, which has unfortunately died. It fell victim to the last global dust storm on Mars. It survived this one that is simulating right here. It shows you how it gets darker and darker and darker. And if you remember Opportunity, whenever it did die, the last message that it sent to Earth, it was a status update, which you could translate as, "My batteries are getting low and it's getting dark." Then nothing. So these global dust storms do have an effect on our exploration of Mars. With an atmosphere and with things like global dust storms, and during the daytime, when the winds are blowing, the winds actually can create a significant amount of erosion. So there is no current water flowing on Mars. In the next video, we will be talking about the water features, about how Mars used to have an active water cycle with rivers and lakes, but there's no longer running water on Mars, leaving just the wind as the major source of erosion. Technical term right here. Wind-based erosion is known as aeolian erosion. Just a cool word. Go ahead and log that one. It'd be a good thing to know, just to see if you've been paying attention to the slides and the videos, so that could become a potential exam question. And with the wind blowing around, it creates some really interesting surface features on Mars. So we see dune fields all over Mars. Here are some Barken dunes, and here's another form of dunes right here. So we see dune fields all over Mars. We even see dune fields at the bottom of craters. So here's Victoria Crater with a dune field at the bottom. Mars is also littered with these geologic features called yardangs as well, which are just these sharp rock features that are carved out where you have softer material, and then the wind blows and it erodes away, it blows away the softer material, leaving only the hard material that gets sort of eroded down as dust blows against it into these nice sharp ridges on Mars called yardangs. So you see yardangs on Mars. And you can see evidence of erosion on this crater. So the erosion is mostly caused by wind, and then whenever enough things get blown away and become structurally unsound, it will fall in. So you can see wind erosion right there. Another really cool weather event on Mars is Mars has dust devils. If you've ever been out in the western part of the US driving around or just looking around, dust devils are very common. They're pretty cool. They can be several hundred meters tall and be pretty wide, about as wide as a highway. One of the most exciting events that I had driving across New Mexico, southern New Mexico, finally, after seeing so many dust devils, one of them was crossing the highway. I was coming down and I drove right through a dust devil. My entire car shook and shuddered as I plowed right through the dust devil. I used to have a strong want to jump into a dust devil, probably a very bad idea, but dust devils are fairly fascinating. And they're small on Earth compared to the ones on Mars. Dust devils on Mars are common in the summertime, and they can be absolutely enormous. They can be several kilometers tall and tens to hundreds of meters in diameters. That means that size-wise, they're larger. They can be larger than Earth tornadoes. Tornadoes are caused by a different effect than dust devils, but the ones on Mars, the dust devils on Mars, can be larger than volcanoes. Here we can see one. It's extending up into the atmosphere a few kilometers, and you can see the shadow that it's casting on the Martian surface. Here you can actually see a dust devil seen by one of the rovers as it was roving by, and it'd be even better. Here's that dust devil, and this is an animation from a rover. Here it is, just streaking on by. So we have captured these things in action. Now, with such a thin atmosphere, they carry a lot of dust, but they don't carry a whole lot of force. with them because there's not very much atmosphere. So sure, the wind speeds are high, but it's not blowing a whole lot of stuff. So it would feel, minus the dust, like probably a stiff breeze. They do provide a very serendipitous event that extended the life of the Spirit and Opportunity rovers much past than what we expected. So Spirit and Opportunity were solar powered. That means that they ran off solar panels. And it was expected that the end of their mission, the end of their life, they would die when dust would cover their solar panels and they could no longer charge their batteries. And we were pleasantly surprised. And this is in 2007, 2008, where here we can see the charging capacity was getting pretty low because those solar panels are very, very dusty. Then one of those dust devils blew over Spirit, and hey, thanks. You cleaned up all those solar panels, extending the lifetime and how long these rovers could go, much past what we expected. Without this, these rovers would have had a much shorter lifetime. So thank you, dust devils on Mars. Finally, I want to talk about Mars has clouds. And I am going to jump back in slides here after we look at these clouds rolling by. So this is from Curiosity rover. Just go ahead, lay out what are you supposed to do whenever it's Sol 2410. You've been hanging around. This would have been the 17th of May in 2019. Might as well just take a little break and watch the clouds roll on by. So here you can see clouds on Mars. These are about 30 kilometers above the surface. And Mars technically has two different types of clouds, which Earth does not. We only have one type of cloud, water-related clouds. So Mars has clouds that are made out of water ice. So these are water ice clouds. And then up above that, where things get colder, Mars actually forms carbon dioxide ice clouds, dry ice clouds. Now I'm going to jump back to end this video to show you here in the atmosphere. So here, another useful thing, this temperature altitude profile, is here you can see the temperature drops to a point where water ice can condense out of the Martian atmosphere. And then as you go up higher and it gets colder, you get a layer of thin carbon dioxide ice that can condense out of the atmosphere. And that is all I have for the atmosphere of Mars. We are going to pick up with the most fascinating topic about Mars, opinion, not a fact, of all the water features on Mars, and then see how they give us evidence that Mars used to be a much different world that had a thicker atmosphere, warmer temperatures, and a water cycle. I will see you in the next video.